Six Sigma, and this is topic of quality toolkit for managers. The subject code is KMBOM-03. Okay, these are some references that you may refer for further study about the topic Six Sigma. So this is second one is a good book about Six Sigma and process improvement, and rest are first book is for quality, and third book is for operations management. And these 4, 5, 6, 7, 8, and 9 are some good blocks about Six Sigma. Okay, so you may get better understanding by accessing these articles as well as these books. Okay, so first we will discuss about what is Six Sigma. So Six Sigma is a quality program that, when all is said and done, improves your customer experience, lowers your cost, and builds better leaders. That is a statement of Jack Welch. Okay, that Jack Welch implemented Six Sigma in GE, General Electric. Okay, so that is basically a statement given by Jack Welch. So Six Sigma is quality program that, when all is said and done, improves your customer experience. It will lower your cost, means it will work for cost optimization, and builds better leaders in terms of means your company performance. Okay, you will become a competitive as you will get a competitive as over your competitor. Okay, so that is basically you will become a leader in market. Okay, so Six Sigma is a set of management tools and techniques designed to improve businesses by reducing the likelihood of errors. Okay, so that is Six Sigma. Basically, it is a management tool and technique, and that has been designed to improve the business by reducing. It has been reduced, and the likelihood of error. Basically, you will notice the error, notice the defects, and you will continuously work towards reducing that error by eliminating or by rectifying the assignable causes associated with this process. Okay, so it is data driven approach that uses a statistical methodology for eliminating defect. Means basically this approach is a data driven, means you will identify what are the parameters for which the data is the means defect is occurring, means what are various assignable causes. Okay, and after that you will statistically monitor it and measure it and map it by process mapping, as I have told earlier about process control chart. Okay, so what is process control chart? Basically by this way you will decide a mean, means what should be your process, as well as upper controllable limit and lower controllable limit of your process. And by this way you will map those process statistically, and where there is a deviation in along the mean, you will notice it and rectify it. So it is based on the Greek symbol, that is sigma. Okay, and sigma is what? A statistical term for measuring process deviation from process mean or target. So Six Sigma comes from the bell curve used in statistics, where one sigma symbolizes a single standard deviation from the mean. So if the process has 6 sigmas, 3 above and 3 below, means the defect rate is classified as extremely low. Okay, means if the process is lying along the mean, that means the defect rate is extremely low. And if they are lying along upper controllable limit and along lower controllable limit, by that way you may see that the defects rate are much higher than the that you are expecting generally. Okay, so basically by this way you will measure your defects, and you will prepare a strategy to mitigate those risks that are occurring, basically defects in your process. Okay, so the graph of normal distribution below underscores the statistical assumption of Six Sigma model. Okay, Six Sigma model. So the higher, generally you have seen that bell-shaped curve. Okay, so what is that bell-shaped curve? Basically mean and upper and lower controllable limit, and that you have divided in 6 parts. Okay, so that is means along the mean, that is basically Six Sigma. So the higher standard deviation, the higher is the spread of value encountered. So the processes where the mean is minimum 6 sigma away from the closest specification limit are aimed at Six Sigma. So Six Sigma is a quality control methodology developed in 1986 by Motorola. Okay, so it was first developed by company Motorola in 1986, and it was originally developed as a management method to work faster with fewer mistakes. Means you will continuously work for work to attain minimum effect and minimum defect, and that is around 3.4 defect per million opportunity. So it has now become an industry standard with certification offered to the practitioner. And nowadays a lot many consultants are there that are providing services in the field of Six Sigma getting a professional certificate regarding such type of practice, means adopting Six Sigma basically. Okay, so if you talk about various Sigma levels, so here is a list of Sigma levels that are occurring in this Six Sigma. So first Sigma, if you talk about your processes, first Sigma, that means only 30.9% good product was there, and 69.1% of products or defects are there. Means if you talk about defects, so 6,91,462 defects are there out of 10 lakh. Okay, so that is basically extreme case. I think most of the companies are lying in 3, 4, 5 Sigma. Okay, and they are continuously working towards attaining this Six Sigma. Okay, so what is 2 Sigma? Basically 2 Sigma is 69.1% good and 30.9% bad, means 308,538 means 3,08,538 out of 10 lakh. Okay, so it is defect level, and DPMO is basically defect per million opportunity, means per million means 10 lakh. Out of 10 lakh, there are 3,08,538 defects. Okay, next is 3 Sigma. What is 3 Sigma? Percentage of good is 93.3%. Okay, and if you talk about bad, so what is that? 6.7, means if you talk about defects, so these are 66,807 defects are there out of 10 lakh if your company is lying in 3 Sigma level. So most of the companies generally lie in between 3, 4 and 5 Sigma. Okay, and they may plan for or plan to attain 6 Sigma. Next is 4 Sigma. So what is that? 99.38% good and 0.62% bad, means 6210 DPMO. DPMO is what? Defect per million opportunity. Next is fifth 5 Sigma is 99.977% good and 0.023% bad, means 233 defects only out of 10 lakhs. So that is much better, and companies that are lying in 3 Sigma, they are working towards getting 4 Sigma and then working towards getting 5 Sigma, and next step would be working towards getting 6 Sigma. That is only 3.4 defect per million opportunity. Okay, so that companies are working for to attain this 6 Sigma basically. Okay, if you talk about evolutionary timeline, so you may see that in 1736, French mathematician Abraham de Moivre publishes an article introducing the normal curve. Means before 6 Sigma, there was a statistical, means they have introduced the normal curve basically that we are using in 6 Sigma. Okay, and in 1818, Gauss used a normal curve to explore the mathematics of error analysis for measurement, profitability analysis, and hypothesis testing. Okay, in 1896, Italian sociologist Alfredo Pareto, you have heard about 80-20 rule. Okay, so introduced the 80-20 rule or Pareto principle distribution in this is means publication where they have published their 80-20 rule or Pareto principle. Okay, next is 1924, Walter Shewhart introduced the control chart. What is control chart? Basically mean, upper controllable limit and lower controllable limit, and the distinction of special versus common causes. Common causes means what are the natural causes, what are the assignable causes, variation as contributor to the process problem. Okay, next in 1970s, this Kano model. Okay, so introduce his 2-dimensional quality model and the 3 types of quality. Okay, in 1960s, I think it would start from here. Okay, not from 1970s. Okay, so 1941, this Osborne, head of BBDO advertising, father of a widely adopted set of rules for brainstorming. Okay, so they have given the concept of brainstorming in 1949. US DOD issue military procedure MILP 1629 procedure for performing a failure mode and criticality analysis. So this was developed in 1949. 1960 Koru Ishikawa introduced his now famous cause and effect diagram, or Ishikawa diagram, or fishbone diagram that you know. Okay, next is 1970. Kano introduced his two-dimensional quality model and three types of quality. After that, in 1986, Bill Smith, a senior engineer and scientist, introduced the concept of Six Sigma at Motorola. So, who was the inventor of Six Sigma? Bill Smith at Motorola Corporation. Okay. Next is 1994. Larry Bossidy launches the Six Sigma at Allied Signal. Okay, so this company adopted this Six Sigma, and after that, in 1995, Jack Welch, the statement that I have given in first slide. So Jack Welch launched Six Sigma at GE. So these, and after that, if you see, a lot many companies that have adopted this Six Sigma. Okay, so General Electric is there, Ford, Honeywell, John Deere, and Johnson and Johnson, Kodak, Service Master, Black and Decker, Sony, Doe, and lot many companies, Motorola, GM. Okay, so if you talk about financial institutions, JP Morgan, Merrill Lynch, okay, AIG, Citigroup, all many banks are there that have adopted Six Sigma in financial services. So these are some examples. Okay, if you talk about key principles of Six Sigma, so these are some key principles. Means first you should identify the defect, and after that solve that defect. So identification of defect or identification of problem is basically where does a function deviate from what should be and what is. Basically means you should decide the mean and upper and lower controllable limit, and notice the deviation, and notice the causes of deviation and rectify it. Basically that is second step, solving the problem. Okay, so is it important enough to need correction? Is there a need to correct that defect or not? Means whether it is considered by customer or not. So is it important enough to need correction, or is it just because of process or something else, or some natural deviation is there? So you should identify the cause for that deviation basically. Okay, next is solving the problem, changing the state of functions from what is on what should be. Okay, so ensuring the change is implemented for achieving the desired goal. As I have told you that most of the companies are nowadays lying on 3, 4 or 5 Sigma. They are working towards getting Six Sigma level. Okay, so if you are lying in 3, 4 or 5 Sigma level, then you will work for attaining Six Sigma by identifying the problem, identifying the causes of variations, or identify the causes of defects, and after that rectifying these or resolving those type of defects basically. So these are the 5 key principles that you should these are the 5 key principles that you should adopt for this implementing Six Sigma. What is this? First is focus on customer. Means your prime concern would be of customer, because this is based on the popular belief that customer is the king. Okay, so the primary goal is to bring maximum benefit to the customer, and for this our business needs to understand its customers, their needs, and what drives sales and loyalty. So this requires establishing the standard of quality as defined by what the customers or market demands. Okay, so basically your prime concern would be of customers. Means you should consider the need of customer, basically what customer is considering as mean. Okay, so that you should consider. Second is measure the value stream and find your problem. Means map the steps in a given process to determine area of waste, gather the data to discover the specific problem area that is to be addressed or transformed, have clearly defined goals for data collection, including defining the data is to be collected, the region for the data gathering, insights expected, ensuring the accuracy of measurement, establishing a standardized data collection system. Means you should properly collect the data. It is a data driven approach basically. Okay, so you should clearly collect the data, and without any biasness, and measure the accuracy of data. Okay, check it and map it properly in your that measurement criteria. Like you will decide mean, you will decide upper specification limit, and you will decide a lower specification limit. So where it is actually lying, you should portray over there in your bell shape curve basically. Okay, statistics, you should model it by using statistics. Okay, so as a certain if the data is helping to achieve the goals, whether or not the data needs to be refined or additional information collected. So identify the problem, ask questions, and find the root causes. Means basically first you should collect the data, and after that analyze that data and find out what are the basic root causes. Means what are the assignable causes and what are the natural causes behind this defect or behind this deviation from mean. So measure the value stream and find your problem. Next is get rid of junk. So what is junk? Means the once the problem is identified, make changes to the process to eliminate variation. Thus, removing defects, remove the activities in the process that do not add to the customer value. And if the value stream does not reveal where the problem lies, tools are used to help discover the outliers and problem areas. So streamline functions to achieve quality control and efficiency. And in the end, by taking out the above mentioned junk, bottlenecks in the process are removed. What is junk? Means pile up of work, or this bottleneck means some regions are there by which low speed production or slow speed production is there. So you should identify the causes of those bottlenecks and remove it to streamline your process basically. Okay, so next is keep the ball rolling. Means involve all stakeholders. Means this is not an functional process, but it is interdisciplinary process. Means you should involve all the stakeholders and adopt a structured process where your team contributes and collaborate their varied expertise for problem solving. So Six Sigma processes can have a great impact on an organization. So the team has to be proficient in the principles and methodologies used. Okay, so hence specialized training and knowledge are required to reduce the risk of project or redesign failure and ensure that the process performs optimally. Okay, so you should design whether what should be the process. Okay, to get those defect at a minimum level basically. Okay, whether is there a redesign required or process improvement is required. Okay, so that you should adopt while dealing with this Six Sigma. Okay, next is ensure the flexible and responsive ecosystem. Is the essence of Six Sigma is business transformation and change. So when a faulty and inefficient process is removed, it calls for a change in the work practice and employee approach. So a robust culture of flexibility and responsiveness to changes in the procedure can ensure streamlined project implementation. And the people and the department involved should be able to adapt to change with ease. So to facilitate this, processes should be designed for quick and seamless adoption. So ultimately, the company that has an eye fixed on the data examines the bottom line periodically and adjust its process where necessary can gain a competitive edge. Means you should ensure a flexible and responsive ecosystem. Means you will maintain that system, you will maintain that defect level only up to 3.4 defect per million opportunity by devising such type of change that you have planned to implement basically. Means if you want to implement process improvement, then you may incorporate it, or otherwise if you have business process redesign or business process re-engineering, then you may adopt this also to overcome the defect level basically, and to optimize it up to the level of 3.4 defect per million opportunity. So that is basically key principles of adopting Six Sigma. Okay, so if you want further study about the topic, or if you want to explore this topic in better way, then you may refer following books as well as blogs for further study. And if you have any query or doubt,